New Delhi as air pollution in the Indian capital hits hazardous levels.
Every year, a public health emergency descends on India.
The percentage of population that's breathing air that does not meet our national air quality standards has increased from about 30% to over 50%.
Improving air quality in India is better than curing cancer. The biggest contributors to pollution in India are PM 2.5 and PM 10. In Mumbai, we carried an air filter with us everywhere we went.
So hello everyone, I hope you guys are doing well. So this video is a continuation of my last presentation video, which was all about air purifier innovation project. I worked as a research analyst over here to find out the best market fit for air pure innovation. While doing research, I find out some insights. So in this presentation, I'll share with you all these requirements and insights. So let's start with this presentation. In the business requirement 2, I was asked to find out state with their pollution size and their average air quality for 2024. So here you can see I have all the state like Madhya Pradesh, Uttar Pradesh, Tamil Nadu, West Bengal, Gujarat, Karnataka, and their total pollutions and their average air quality index. I use a color validation to understand the visual better. Like Maharashtra have the highest population, whereas average air quality is moderate, and the data is only for 2024, where you can see West Bengal has a moderate total population, but the air quality is high. Also same goes for Delhi. You can see Delhi 2024 total population was only 65k, but their average air quality index was 208.93, which was a high risk zone. So let's talk about the insights. Maharashtra has 187k population with a moderate air quality. Tamil Nadu has 125k population with a lower air quality index. On the other hand, Delhi have a moderate population with high air quality index, whereas Himachal Pradesh has 2.3k population in 2024 with a air quality index of 166.45, which is a very bad air quality index. In the southern and coastal areas, you can see Kerala has 84k population with a air quality index of 64. Pondicherry has 3.5k population with a air quality of 54.63. These are resulting in a very clean air, you can say. So the answer of the question, does larger population always means a bad air quality index? No. So the answer is no. Larger cities does not always suffer from the baddest air quality. For example, Maharashtra and Tamil Nadu, this state has the highest population in India, and they are maintaining moderate air quality level like 99.17% and 61.82% respectively. For the strategies takeaways for air pure innovation could be introduce proactive health focused campaigns in the state like Maharashtra, Tamil Nadu, where AQI is moderate but the health conscious urban population exists. For the tier 2 cities like Bihar, Rajasthan, focused on affordable mass market purifier variant. Now talking about second business requirement from the secondary business analysis, which was to find out major competitors in India in the air purifier market and their key differences. Here you can see we have some brand like Dyson, Honeywell, Kent, Realme, Xiaomi, Blue Star, etc. and their pricing range vary to 6 to 35Ks, where their filtration stage, you can see their filtration type, their smart feature, their filter, and their key differences. So from this visual, we can observe some insights like primary segment like 30 to 55K. Dyson company dominant in this price range with a high-end design, Wi-Fi and apps control and advanced HEPA filtration. So air pure innovation can target Delhi NCR, Mumbai to offer some premium and aesthetic air purifier. An upper mid-range like 15 to 13K, Sharp, CoAF, Philips stand out with a specialized filtration like plasma cooler, antivirus, HEPA, nano protect. So these brands focus on feature rich, health conscious and families on tier 1, tier 2 cities. So air purifier can compete with here with a health plus value positioning, like offering a equivalent filter with a low price and targeting polluted state like Uttar Pradesh and Rajasthan. And budget segment like 7 to 15K. Here Realme, Kent, Blue Star, Xiaomi, they are dominating this segment. So here focusing on basic HEPA plus carbon filtration, compact design and app connectivity can be a good option. And focusing on middle class families like tier 2 cities, Bihar, Haryana, West Bengal can be a game changer for air pure innovation. And most importantly, what air pure innovation can do right now, avoiding ultra premium entry. So initial phase, air pure innovation needs to be avoid this segment. Instead, they should use affordability and localized innovations as a core USP. Now moving ahead with the health impact page, here in the secondary business analysis, I was asked to find out few research for those questions. You can see in the green bar which pollution control policies introduced by Indian government in the last 5 years and have had the most measurable impact on improving air quality. So let's find out the research point. So the top 3 government introduced policies are like National Clean Air Program, NCAP, launched in 2019. It is a nationwide mandate covering 131 non-emitment cities with a goal to reduce PM2 and PM10 by 20 to 30% by 2024. Now revised by 40% by 2026. Impact since improved PM10 levels in 103 of 130 monitor cities like Mumbai with 44% reduction. Kolkata improved by 37%. Varanasi registered a 72% reduction in PM2.5 and 69% in PM10. One of the best performer under NCA. Second policy is Bharat Stage 6 VS6 emission stand enforced April 2020. It was introduced to control and cleaner fuels across all vehicles. Talking about impacts in cities with quality fuel ability and vehicles age compliance like Delhi and Mumbai show a tangible improvement in winter air quality peaks and traffic related PM spikes. And the third policy is Graded Response Action Plan GRAP, launched in 2017 and updated in 2022. It is a system of pollution control action like traffic restriction, construction bans, diesel generator shutdown. So all these activities when air quality crosses threshold in Delhi NCRs and other metros. Impact since short-term relief during pollution alert like construction bans, restrictions on diesel powered generators have had a limited long-term impact. However, areas like Punjab and Delhi NCR show reduction during some population spikes through overall winter baseline, and air quality remains high due to regional emissions. So by introducing all the three government policies, Delhi NCR is improving, but winter air quality is still high due to stubble burning and regional power emissions and etc. Chandigarh and Punjab mixed result. They are improving, but sometimes they are decreasing their air quality, sometimes they are improving their air quality. Also, you can see Mumbai and Kolkata, they are the top performance. Under NCAP scheme, Mumbai leading with 44% PM10 reduction, where Kolkata achieved 37% result. Now talking about which age group is most affected by related health outcomes and how does this vary by cities. So in the research point, you can see the age group impacts by city region. Children under 5 years, most baddest to air pollution, experience nearly 100 to 120% increase mortality risk. In these areas, they crossed the national PM2.5 limits in 2020-21. Over 1.6 lakhs deaths among Indian children under 5 years, and these were found out linked with air polluted in India, making it the second leading risk factor after malnutrition. In Delhi alone, 2.2 million children suffer lung damage. Talking about newborns and infants, newborns face 86% higher mortality risk. Older adults like this age shows a cardiopulmonary risk for both ambient and household air pollution, especially in urban exposure. So yes, air pollution is affecting on our health heavily from children to age of 60 plus. Moving ahead with the third question, how aware the Indian citizens of what air quality index means and do they understand about the health implications? So let's find out the answer. Awareness exists, but understanding is shallow. Over 90% of urban population in the cities like Delhi, Kolkata, Chennai, Bengaluru, Pune, Maharashtra, they say they are aware of air pollutions, but only 54% understand air quality index, and 29.6% know about PM2.5, and just 17.8% recognize PM10. Specifically in Delhi NCR slums, only 10% of poor population understand terms like air quality index or PM2.5 compared to 71% awareness among the middle class areas. Talking about air quality to health impact, while 93% Indians agreed air pollution harms death, just 13% actively monitor air quality daily and 12% never check it out. So the conclusion is high nominal awareness exists, especially in metro cities, but deep understanding of air quality index and related to the health risk is very limited. And point 2, lower income and less literate groups are not even aware of air quality index, and they are even in a high risk. This is a critical barrier for public health policy effectiveness. Last but not the least, I was asked to deliver this dashboard with state risk score, pollution size and income, air quality index, etc. And this data is important from government data sources. Here you can see I have created a table chart. I have all the states with their air quality severity index and their population density, their per capita income, state risk scores and state risk scores band. So for example, you can see Andhra Pradesh has the air quality severity index 1, which is high, and population density is 9.4 per square kilometer, and their per capita income is on the moderate side, where the state risk band is moderate risk. Compared to Delhi air quality index is high, also their population density is high, their income side is good, their state risk is very high. Talking about the research and insights, let's talk about Delhi. So Delhi has a air quality severity with 0.99% and population density is 1135 per kilometer square foot. So these are extremely high, and with per capita income 4.6 lakh, Delhi earned the city risk score massively. So this makes Delhi a critical high priority intervention zone. And talking about Haryana, Chandigarh, both cross the air quality index like 0.9 to 1% respectively, but their per capita income was strong 2.96 lakhs to 4.9 lakhs, making them a high risk market with high purchasing potential. Talking about Bihar and Assam, so here air index severity scores are 0.98 to 0.88, but the income is low 60k to 1.1 lakhs. So this region faces serious health risks but may not have that purchase power of premium products. So this area requires a policy level intervention and affordable solution. So in a conclusion, we can say high air quality index plus high density plus high income is equal to business hotspot like Delhi, Chandigarh. On the other hand, high air quality index plus moderate density plus high income is equal to emerging markets like Kerala, Haryana, Pondicherry. Similarly, high air quality index plus low income is a health risk but low commercial feasibility like Bihar and Assam, and the low air quality regions like Goa and Arunachal Pradesh is equal to low business priority. Also in this Power BI page, you can see I created a total death KPI of high risk state and the air filtration to filter out the dataset according to the business need. Now talking about the critical questions, so I was asked to find out the answer priority cities, which tier 1 and tier 2 cities show air quality degradation. Here you can see I have created a table chart to showcase the states, their tier 1 and tier 2 cities and their average air quality index. So tier 1 cities like Delhi, Greater Noida, Ghaziabad, Lucknow, Kolkata has air quality index like 2.06, Noida has 184, Ghaziabad has 183 and Lucknow has 131 and Kolkata has 102. And tier 2 cities like Begussarai, Bihar, Muzaffarnagar, UP, Patna from Bihar, Moradabad from UP and Gurugram from Haryana, their air quality like 206.7, Muzaffarnagar had 175.6, Moradabad had 104.1 and Gurugram had 190.8 air quality index. Talking about the key insights, Delhi NCR belts like Delhi, Ghaziabad, Noida, Faridabad, Gurugram is facing irreplaceable air quality degradation due to dense urbanization, industrial belts and vehicle emissions. And cities like Lucknow and Kolkata, however, they have moderate degradation levels. Given their population and urban style, they remain high risk zone for a long-term health impact. And the next question was health burden. How do air quality spikes correlate with pediatric asthma? So here you can see the research point. So air quality spikes versus pediatric asthma admissions. So Delhi sees 20 to 25% surge in child asthma admissions during air quality spikes above 400. In Mysore and Ahmedabad, even small areas in PM 2.5 and NO2 air pollution levels correlate with 8 to 16% higher risk of pediatric hospitalization, where Bengaluru has experienced a jump from 9 to 25% asthma prevalence in children over the last 5 years with a 15% increase. So in short, the research insight short-term air quality spikes PM and NO2 lead a immediate and measurable increase in pediatric admissions. Even moderate air quality areas like tier 2 cities significantly elevate hospitalization risk for young children. Now talking about the next question, behavioral shift. Do population emergencies increase purifier search and purchase? In this research point, you can see air quality search triggers immediate sales lift. Delhi NCS. Whenever air quality hits high to severe zone like 300 to 500 range, the demand of purifiers spikes significantly. Retailer reports that 50 to 70% increase in daily sales. In quarter 3 2023, shipment rose 64% year over year. Demand increase in Mumbai, Bengaluru, Chandigarh and Ludhiana when the air quality level is increased extremely. So the summary inside, yes, population emergencies correlate closely with spikes in air purifier sales and consumer inquiries. So the last question was feature gap. What do existing product lacks in the air purifier market? So now talking about the research point. So many air purifiers models like they are offering app control, air quality display, real-time syncing with real quality data, but no direct integration to auto-adjust setting dynamically as external air hostess, compact wall mount and modular design. Most models are catered to floor standing units with a bulky footprints. So no compact, no wall mounted variants for small apartment. And last is affordable AI and ML model feature in the mid-range segment. AI feature feature like adaptive learning based. So the opportunity is to bring air-powered air purification in 10 to 20k segment. Now talking about the deliverables, the number one ask was city risk scores, which I already shown you in the health risk page. I have also shared the cost impact. Competitor feature gap I already shown you previously, and the product requirement must have features I already showed you in the feature gap question answering. And the last was triggered pricing models for target segment. In the competitor analysis of the product, I have shared pricing can be the best suitable for the targeted areas, targeted cities, targeted states. So yeah, this was all about the secondary analysis of my last shared presentation video. So I have tried to answer all these questions. So if you like this video, please do let me know in the comment section where I can improve more, and definitely I'll get back to you very soon with the next project. Till then, keep breathing.